you see here, these little googly eyes, if you will, they're actually clickable. So if I go to Eugene, they're supposed to have peak annularity beginning at around 9:17 a.m. Pacific. If I click on this little googly eye, it'll snap right to that time, and you can preview exactly where it's going to be. So you still have plenty of time to start getting up to speed with exactly what this annular eclipse or partial eclipse is going to look like in your neck of the woods. So I certainly encourage you to play around with this tool. And if we go to our real-time view of it now, you can see that a partial eclipse is already impacting a very large portion of the United States, stretching all the way out to as far as Nashville. And so very excited for our moment in this partially eclipsed sun here in Kerrville, Texas. We're expecting that to begin at around 11:50 a.m. local. I'm going to continue to track the movement of this annular eclipse across the U.S. But for now, back to you, Tahira.
Thank you so much, James. So excited to see that first instant of the Ring of Fire effect soon. Now, Gina and I are joined with Leslie Garrison.
Hi, Leslie.
Who is going to show us how to make a pinhole viewer to observe today's events if you do not have your eclipse glasses.
Yes.
So, Leslie, I see you've got a few different pre-built pinhole viewers with you right now. Can you first just walk us through how this even works?
Yes, absolutely. So, to safely view the sun today, we brought a couple of items. We have a colander, a pinhole, a peg hole, a sheet of cardstock, and a hole punch. And so we're going to use them to simply create what we call a pinhole projector. And so in order to use these or to make these, you need a few items from home, but number one, make sure to never look at the sun directly, but number two, make sure when you are making and creating and using these that the sun is to your back so that the sun's light can cast light through the holes.
And you just, what, put it up and have it
coming
put
through.
a shadow on the ground?
Absolutely, and so on the paper model, we are going to put a hole here, and the light is going to go directly through it. Peg hole, the colander, and the NASA 3D printed model already has a hole. All you have to do is wait for the eclipse to happen and see the view of the sun on a surface area.
That's great. So Leslie, can you go over those materials just one more time?
Absolutely. So at home, you probably already have a colander. This is just a pegboard toy from my son's toy box, and a sheet of cardstock and a hole punch. But NASA has a cool event online. You can see our URL somewhere on our screen, and you can go online and make these items at home to use.
So really you just need something with a hole.
You need something with a hole.
Yeah.
The sun's light can shine through, so on the surface area, and you can see the eclipse on that surface area.
Simple, effective. Yeah. Leslie, thank you so much for your help today.
Leslie.
And folks, this is a good time to remind everybody that it is dangerous to look directly at the sun without specialized eye protection for solar viewing during today's events. Now, we have a very special guest that you might recognize popping in to share some important tips to make sure that you stay safe during an annular eclipse.
Hi, eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. During an annular eclipse, it's not the moment for a sun staring contest. Grab those eclipse glasses and shade your eyes from the Ring of Fire. What you'll witness is a true cosmic marvel. The moon will move between the sun and the earth, but the moon is a bit too far away from Earth to completely cover the sun. So, when you look up at the sky during this annular eclipse, you'll see the sun creating a glowing ring around the moon. Because the sun is never completely blocked, it is never safe to look directly at an annular eclipse without special eye protection for solar viewing. This I promise you. You should wear eclipse glasses so that you don't say bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Now, don't forget to be in sync with these safety tips, folks. Seriously, listen to Lance and protect those eyes. We really want everybody to enjoy today's events. Now, let's check in with Joy and Michael in Albuquerque, New Mexico. Joy, Michael, how is the energy over there?
Hi, Tara and Gina. The energy in Albuquerque is buzzing. We are so excited for the annular eclipse to pass through New Mexico in just under an hour. I'm joined with one of NASA's eclipse experts, Dr. Michael Kirk. Thank you so much for joining us.
Oh, it's an absolute honor and a privilege. I'm so excited to be here today.
So we're currently on the grounds of the Anderson Abruzzo International Balloon Museum in Albuquerque, and behind us, the Albuquerque International Balloon Fiesta is also happening. And in fact, a balloon is also about to get inflated right behind us, which is really, really exciting. So Michael, have you seen an annular eclipse before?
I have seen an annular eclipse in New Mexico back in 2012, but this is a special event here today. With the balloon fiesta going on, there are literally thousands of people behind us, all getting ready for this event. This is one of the most special eclipses I've ever been to.
This will be my first annular eclipse. I'm really excited, and the skies are looking really clear, so I have my fingers crossed that it stays that way. So we have these incredible balloons over the past week, but did you know that NASA also does science experiments and develops technology using balloons? They're slightly different from hot air balloons. So to learn more, I chatted with Chris Yoder from NASA's Scientific Balloon Program. Hi Chris, thank you so much for joining us.
Thank you for having me.
So you're part of NASA's balloon program. What is the difference between a NASA scientific balloon versus a regular hot air balloon?
Good question. So hot air balloons are air-filled, and the air is heated to create the buoyancy through the lift that gives them flight. Generally, they float at a couple thousand feet, and they go up and down in a matter of hours. Scientific balloons, on the other hand, are quite different. So our largest balloons can fit a football field inside their equator, and they can fly for much longer. So payload capacity is about 8,000 pounds, several SUVs. The duration can be up to 5 or 6 weeks at a time, and the altitudes can be up to 160,000 feet, about 4 or 5 times the height of a commercial airliner.
Wow.
So quite a bit different, yeah.
That's incredible. And you launch all over the globe. So you launch from New Mexico in the US, New Zealand, and even McMurdo Station in Antarctica. Why do you launch from all those different places?
In short, we go where the science needs us to go. Some scientists need Northern Hemisphere science for galaxies and star formations. That's why we go to Sweden. Same thing in the Southern Hemisphere. That's why we go to Antarctica. Most missions need some kind of trial or test system, so they'll fly from New Mexico to prove their science or even just collect science at a shorter duration. And then for missions that are a little more risky, we'll go out to PMRF in Hawaii.
So can you describe to me what launch day is like?
It's an incredible feeling, right? So you see the balloon be released, you hear the rustle of the fabric and the rush of the wind as it stands up. You see the balloon be released on the vehicle and ascend, and it just gives you chills every time you watch it. It's a really great feeling.
That sounds incredible. So how many of these balloon experiments have been sun-focused or eclipse-focused?
So about 8 to 10% of our portfolio is heliophysics missions. One of the ones that stands out in my mind is one I got to see launch in 2019 from New Mexico. It's called the BITSI mission, and it was looking at the corona, or the kind of the outer edge of the sun, and looking at how that behaves under different conditions.
That sounds amazing. Thank you so much for joining us.
Thanks again for having me.
Our balloon program has been around since 1961, so it's no surprise that our balloons are constantly innovating and discovering new science. So let's dive into some of the big science discoveries that have been made with scientific balloons.
High above Earth's surface floats a critical tool in NASA's exploration arsenal: scientific balloons. Massive, helium-filled, high-tech balloons lift heavy scientific experiments into near space to get a clear view of our planet and the cosmos. Launched around the globe, these unique NASA missions provide a fast and cost-effective alternative to rockets to study Earth, our solar system, and beyond. Balloon science has led to many important discoveries. For example, astrophysicist John Mather studied heat from the early universe using balloons, which later contributed to his Nobel Prize-winning work confirming the Big Bang theory of an expanding universe. A special type of high-altitude balloon can carry telescopes above the clouds for extended periods of time to study the dark matter in distant galaxy clusters. One of these superpressure balloons, called SuperBit, captured the Tarantula Nebula 160,000 light-years away. This winter, crews in Antarctica are preparing to launch the Gusto mission. Its infrared telescope will examine the complete life cycle of a star. NASA's scientific balloon program, guiding a path to discovery above and beyond.
Joined with us now is the Balloon Museum Manager, Nan Maslin. Thank you so much for joining us on probably the busiest week of the year.
I'm so happy to be here with you all.
So we're here, the Fiesta started in the 70s with a small group of people, and now there are hundreds of balloons. Can you tell us more about the event and what it means to the city?
Absolutely. Well, it started in 1972 by a pilot named Sid Cutter, who had the idea to get a few hot air balloons together. He managed to get 13 together in a mall parking lot, and they expected a handful of people to show up, and hundreds did. And that's when he knew he was really on to something. And 51 years later, there's 100,000 people behind us on the field right now.
Oh my goodness. So the Balloon Museum, it's where you work and it's where we are right now. Could you tell us a little bit about the relationship between the Balloon Museum and the Fiesta itself?
Absolutely. We are very good neighbors. We are here 365 days of the year. We started in 2005, and we start with the early ballooning in the 1700s up through today, exploring the history, science, art, and just wonder of ballooning. And if you haven't been to Albuquerque, we invite you all to come back and check out this museum.
And what do you love most about the Fiesta and the museum this week?
New Mexico is such an enchanting place to be, and the smell of roasting green chili in the air, there's nothing like it. There's a reason why Georgia O'Keeffe chose this place as her home. It's because of the open sky and the beautiful landscape, and we get to enjoy so much of that here. And when you think about it, there's like a spotlight shining on Albuquerque, and I think it's probably the best place in the whole wide world to be right now. Today, Balloon Fiesta and an annular eclipse. I can't imagine anything better.
And how do you feel about an annular eclipse falling at the same time as the event this year?
It's just fantastic. I'm so happy to be here with you all, and Mother Nature has provided us the perfect sky today. Looking this direction, I don't see a single cloud. There's a bite out of the sun already, like it's bitten out of an apple, and I just am so excited to see the annularity.
Amazing. Thank you so much for being with us today. I'm really excited to enjoy the annular eclipse together.
Me too.
So next, we are honored to hear from NASA Administrator Bill Nelson.
Hey everybody, we're so excited that you're joining us today for this solar eclipse. It's when the moon passes between the Earth and the sun. It's a big day for NASA scientists because eclipses present unique opportunities to study the sun. And what we learn from these eclipses, along with our heliophysics research, has incredible benefits for our human exploration. The sun is a powerful, hot, glowing ball of hydrogen and helium, and it actually holds together the entire solar system. Without its energy, we couldn't exist here on Earth. Just think, it influences everything. What we do on Earth, growing crops, our economics. It even affects our physical, mental, and emotional well-being. We see its influences reflected throughout our culture as well, in art, music, religion, sports. And when you look up today with your eclipse glasses, I hope you're going to remember all the ways that the sun impacts us. NASA will never stop studying our closest star for the benefit of all of us, terrestrial beings here on planet Earth.
Thank you, Administrator Nelson. So, Michael, we've been getting a lot of questions on social media. Shall we dive in?
Yeah, let's do it.
Okay. So I have a question here from Priyesh Patel on YouTube, and they ask, do events like eclipses occur in a similar pattern geographically?
Oh, absolutely. Geographically, we get the same sort of shape of an eclipse that will move slightly northward in its progression. So this is called the Saros cycle. And every 18 years or so, there's a repeated pattern of an eclipse, and the pattern itself repeats a little bit further north each time. And so we get these overlapping patterns that are exactly the same over time.
Amazing. I didn't know that.
Yeah.
That's really surprising. Okay, and before I go on to my second question, I just want to mention that in the telescope view now, we are seeing a partial eclipse and a lot of bite out of the sun.
Oh yeah, it's getting a bit bigger. We're not quite to 50% yet, but yeah, it is getting there. It's pretty exciting.
That's so exciting. Okay, so the second question I have is Sammy Connor on YouTube, and they ask, how does the Ring of Fire eclipse affect the light from the sun reaching Earth?
Ooh, that's a fantastic question, because this has something to do with the science that we can do with eclipses as well. So as the sun gets blocked by the moon progressively, there are parts of the sun, active regions specifically, that will be blocked, and the light from the active regions won't be able to hit the Earth's atmosphere. So we can actually study the effects. We can actually study these effects. We'll hear a little bit more about this later in the program.
Amazing. Okay, so a third question is, one of our viewers on YouTube asks, how do eclipse glasses work?
Ooh, that's a great question.
So these things.
Yeah, we have eclipse glasses. Okay, so you see the lenses right here. This is a mylar film, and the coating on it blocks over 99% of the white light that comes here. Not only that, but it also blocks infrared and ultraviolet light, so it keeps your entire eye safe. So it's really that coating that keeps us safe from the powerful sun's light.
I'm glad.
Yeah, me too.
Thank you so much, Michael.
Of course.
So remember, wherever you're watching in the show, ask a question in the comments below using the hashtag AskNASA, and we'll be answering more later today. So now let's head back to Tahira and Gina in Kerrville, Texas.
Thank you, Joy and Michael. The weather looks great in Albuquerque, New Mexico.
It does, yeah.
So, folks, if you're just joining us, we're following the 2023 Annular solar eclipse as it sweeps across the Americas. Now, coming up soon, James at our Eclipse desk will be plugging us into our very first views of annularity taking place in Eugene, Oregon. Now, Gina, as we anticipate this beginning first moment, can you walk us through what exactly is happening when an annularity takes place?
Sure. So when the annularity is taking place, that's when the moon is going to be in front of the sun. Now, for the annular eclipse, it's not going to completely block the sun, so we'll have that ring of fire that we get to see in the sky. And if you take a look at that live feed from the telescope that we're seeing right now in Kerrville, we already have a bite taken out of the sun from our perspective as well.
Wow, and so that's just going to pass directly over, but not fully cover it.
Exactly. We'll still have that ring peeking out.
Beautiful. And I mean, we're seeing something, but will anything else happen? Like, will we feel anything?
Yeah, so that's the fun thing about these solar eclipses is the fact that there will be environmental changes. So we'll feel that temperature drop, maybe a change in humidity and wind as well, but also nature will respond. So check out, how it feels around you. The birds will nest and go back to their trees. The crickets will come out, starting to chirp. It'll feel kind of dramatic when this happens too.
Can't wait to feel that with you today. And folks, I mean, it's not just us here on Earth plugged into today's action. Emily Ferfaro with NASA Communications had a chance to chat with two astronauts aboard the International Space Station to learn more about the sun from their unique perspective off our planet.
Jasmine, Satoshi, this is so exciting to be talking with you. This is the coolest thing that I've ever done. As you know, all eyes are going to be on the sun on October 14th as we experience an annular solar eclipse. And so I'm wondering, have either of you ever seen a solar eclipse of any kind?
Emily, actually, coincidentally, my very first day at NASA was August 21st, 2017. Which was an incredible solar eclipse. All my classmates and I got to go outside and stare up with everyone. Pretty much everyone else at NASA was outside in those moments looking at the solar eclipse. So that's something I'll always remember.
Wow, oh my gosh, what an incredible first day that must have been. Solar eclipse events provide scientists with a unique opportunity to study the sun in different ways. So with that, I'm wondering, how do you study space weather and impacts from the sun on the International Space Station?
Well, Emily, from the International Space Station, we have a really unique vantage point looking back at the Earth. But also there are several experiments actually mounted right outside here on the Japanese experiment facility outside of the GEM module.
Regarding the space weather, specifically from solar flare activities point of view, a specialists on the ground kindly observe it continuously, and when there is a big solar flare, they notifies it of us, and we move to a relatively safe place on the International Space Station.
Wow, I am so glad that you're well protected up there on the International Space Station. I want to touch back on the annular solar eclipse. This celestial event kickstarts NASA's Heliophysics Big Year, which is a global celebration of sun science and a year where we're inviting the public to do as many sun-related activities as possible. And so I'm wondering, what is your favorite thing about the sun?
Well, Emily, for me, I don't particularly like the dark, and I don't particularly like being cold. So I'm a big fan of the light and the warmth the sun brings. We wouldn't be the planet we are without the sun.
Yeah, Emily, I echo Jaws, and I like the brightness and the warmth of the sun, and I'm looking forward to the next solar eclipse.
That reminds me of something that my friends in heliophysics say, which is that the sun touches everything. With that, I want to thank you so much for taking the time to chat with me today about the sun, and I hope that you both have a great view of the eclipse wherever you might be, and good luck with the rest of your mission.
Thanks so much, Emily. Have a good one.
Station, this is Houston ACR. Thank you.
I mean, how cool is that? Can you imagine seeing the shadow of an eclipse on Earth from space? It would just have to be incredible. Now, folks, the crowd is growing here in Kerrville, Texas, as we inch closer to our moment to witness that Ring of Fire effect in person. Now, it's a good time to check in with James at our Eclipse desk. James, how are things looking on your end?
Hate to hear, yes, so we're still just a little bit away from the annularity here in Kerrville, Texas. Really cool to see the science going on in the International Space Station. Coincidentally, there's actually some really cool science going on just a little bit to the west of us in just a few moments in White Sands, New Mexico. And right now I'm actually joined by scientist Jamie Favors, who can walk us through exactly what we're about to see with the sounding rocket launch. Jamie, thanks so much for joining us.
Thank you so much, James.
Yeah, so is this your first annular eclipse?
It is, yeah, and first time launching rockets into an eclipse too, so.
Amazing, and we're about to have the first of 3 launches. I understand we're kind of timing these launches out to specific times here, right?
Yeah, so you're exactly right. So we'll have 3 launches during the eclipse, about 35 minutes before the peak. That'll be this first one, right in the middle of the peak, and then 35 minutes after the peak. Studying that upper atmosphere, the ionosphere, kind of see what are those impacts from the sun that really change, important features of the upper atmosphere that impact things like radio communications, satellite operations. Yeah.
And we just had a launch yesterday in Cape Canaveral, Florida, of our Psyche mission. That's going out into deep space, but these rockets, which just launched actually here,
Perfect.
Just took off, so this is actually going to come back down afterwards.
That's right. So we're seeing first stage burnout here about 6 seconds in. Blink out for a second, so the rocket's still moving along. There we see the rail, the pad that we just launched from. So as we're launching into space, we're going to start making measurements roughly about a minute into launch. So we're a few seconds in now. I bet we're getting pretty close to the second stage lighting off at this point to take us all the way into space. So roughly that 1 minute mark is where we start to do a lot of the science. The payload separates from the rocket. We have some deployables we'll release from that payload out at that point. We'll start moving that payload around in space so that it's starting to make good measurements. We have these booms or arms that come off of the payload, start making different measurements there of like magnetic structures, electric structures in the upper atmosphere, as well as temperature and density. One way to kind of think about this, what the shadow of the eclipse is doing in that upper atmosphere is it's creating these waves as all those temperature and density changes are occurring. So kind of think about it in the way of like a boat moving through the water.
Yeah.
We've all seen a boat move and you see the waves propagating out from it or moving away from the boat. That same thing is happening here with the eclipse and that shadow. So with those 3 rockets, we're launching one right before the boat moves through,
Yeah, exactly.
one right in the middle of the boat coming by, and then one right after the boat moves through, or the eclipse shadow.
Sweet. And so we are just now a couple minutes away from actually getting annularity here in Kerrville, Texas. Our first view is actually going to be up in the Pacific Northwest, up in Eugene, Oregon. They are going to be experiencing this starting at around 9:17 local time. Jamie, thank you so much for joining us. Best of luck for the next 2 launches.
Yeah, thank you so
And
much, James.
Back to you, Tahira.
Wow, I mean, if the day wasn't exciting enough, now we've got a rocket launch in the mix. This is
It's so exciting.
It's
This is great.
incredible. And I mean, what a NASA broadcast, right? And so thank you, James and Jamie. Now, Gina, we have a lot of great questions rolling in from our viewers online. How do you feel about taking a few?
Let's do it.
Okay, let's do it. So our first question is from Entertainment on Facebook, who asks, how often do eclipses happen?
Great question. Well, thank you for that. So there are actually eclipse seasons. And so we can get eclipses about 2 to 3 times a year. You might expect them to happen every time there's a new moon, but that's not the case because the orbit of the moon is tilted by about 5 degrees, which means sometimes the shadow is a little too high and it doesn't hit Earth, and sometimes a little too low. So we need those eclipse seasons as that sweet spot.
Okay, nice. And so I actually have a really great follow-up to that.
Okay.
Spectacular Science Podcast on YouTube asks, how do you predict solar eclipses then?
Okay, well, it's actually pretty straightforward how to calculate the eclipses because we have a good understanding of the moon's orbit. We have a good understanding of the Earth's orbit and how that whole system is connected. And so we kind of take the geometry and the inputs that we have, and we're able to pretty accurately predict those eclipses. And so these are things that we can look out decades in advance to understand when eclipses can occur.
Oh, cool. And so how often would an eclipse pass in the same city? Do you know?
Well, so for total solar eclipses, it's very unique for an eclipse to pass more than, it's about once every 375 years that a location can experience it. So it's pretty hard to be in the same spot to see a total solar eclipse more than once.
Awesome.
Yeah.
So we have a user on X who asks, will the International Space Station photobomb the eclipse? That would look very cool.
Yeah, and so we just got to hear from the International Space Station, and the unique thing about our astronauts on board is that they have a totally different vantage point for studying the eclipses, and they get to actually view the shadow of the moon as it passes over the Earth. And there are experiments that we have on board the space station as well. And so, with NASA, we have all of these different eclipse experiments that are taking place, and we try to take advantage of every perspective that we have.
Awesome. So we have a final question from Dante. This is going to be a quick one.
Okay.
But Dante on Facebook, who wants to know, will the moon block solar wind along its path during this Ring of Fire eclipse?
Oh, I love that question. So the solar wind is actually a stream of charged particles that's constantly coming off of the sun, and it interacts with the Earth and other planets in our solar system. Now, the Earth's magnetic field actually blocks a majority of those particles from interacting with Earth. Some are able to get through and interact with our upper atmosphere, but for the sake of the eclipse, most of the particles will still kind of be able to be deflected around the Earth's magnetic field. There will be some that are able to interact with the moon, but it wouldn't have a huge impact on what we experience at Earth.
Fantastic. Thank you so much, Gina. And thank you to
welcome.
everybody sending in these questions online. We will get to some more of what you want to know by later on in the show. So keep sending those questions in using the hashtag AskNASA. Now let's check in with Joy and Michael to see what's new in Albuquerque. Joy, how's it going?
Thanks to her and Gina. So we're just under 30 minutes away from annularity in Albuquerque, New Mexico. Michael, shall we put on our glasses to see what the sun and moon are doing?
Yeah, let's do it.
Okay.
Okay, so you're seeing a deep partial solar eclipse. More than half of the sun is blocked out, and so you just see a crescent of sunlight peeking out.
Wow, that is amazing. Annularity is just going to be stunning. I can't wait.
Oh, I can't wait either. This is terribly exciting. You can see a balloon inflating behind us. We have annularity coming. It is all coming together today.
I just can't believe that an annular eclipse is happening at the same time as the fiesta.
It really feels special, doesn't it?
And actually, earlier this week, I even got to fly in a hot air balloon, which is just amazing.
That's fantastic.
I met an amazing balloon pilot, Jonathan Wolf, who's been launching balloons in Albuquerque for decades. So let's take a look at our ride. So for complete newbies, how does a hot air balloon work?
It's a great question. It's physics, simply. We heat up the air inside the balloon, and that makes it less dense, and then that makes it float. Now, what that means, though, is we can only control up and down. The way we fly and the way we navigate is by choosing different layers of air to fly in.
And I've heard that there is a box, the Albuquerque box. Could you explain what that means?
Certainly. It's one of the reasons why Albuquerque is a famous place for ballooning. Sometimes what happens is at a higher elevation, the wind is going to the north, and at the surface, it's going to the south. That's what we call the Albuquerque box. Sometimes the box works out such that you can fly to the south and go up, fly to the north, and then come down and fly back south and land right where you took off, which is an extraordinary and wonderful accomplishment. It's super fun when you can do that.
So for someone who's never been in a balloon, what is it like?
It's unlike any other form of flying. In a balloon, you're actually outside, right? You're standing in a little basket, and there's no windows. You're just out there in the air, and it's just science, right? It's buoyancy, like I said, it's applied physics, but it feels like magic. It's a ballooner eclipse.
Oh yeah!
I love that. It's very calm. There's no movement, no wind. When you're moving with the wind, so you're at equilibrium. It feels very calm and peaceful. At the same time, it's really exciting and it's intense. So it's this wonderful combination of intensity and mellow, serene, tranquil, beauty, absorbing nature. You can never experience that in any other form of flight.
Wow, that brings back great memories. And if you can hear the wind behind us, they're actually inflating the balloon I rode in just behind us, which is so cool.
So was that your first balloon ride?
It was my first balloon ride, yes.
Oh my goodness, how did it go? I remember taking one about 20 years ago and it was fantastic. What was your experience?
The most surprising thing is that when you're up there, you don't feel any wind against you,
right,
because you're actually moving with the wind, so it feels completely calm.
Oh, that's fantastic. So would you do it again? I found it terribly relaxing.
100%, yes. So it was actually also not that chilly, and we were only a few hundred feet off the ground as well.
Wow, that's amazing, because it's been chilly here all morning.
So as we learned earlier, NASA's scientific balloons fly much higher. They actually reach a part of our upper atmosphere where our International Space Station lives and where some of our satellites fly as well. So it's really important we learn about this upper region and how it could affect our lives on Earth. And NASA and NOAA are two agencies in the US that work together to help study this. And I'm joined with two people who can tell us more. So we have Dr. Elsia Talat from NOAA and Dr. Kelly Corrick from NASA. Thank you both so much for joining us.
Very excited to be here.
Very excited to be here. Thank you so much.
So let's start off with the basics. Elsia, what are those changes we see in that upper region?
Well, part of what we call space weather, which is the variable conditions on the sun, the Earth, and near Earth space due to solar and geomagnetic activity and storms. And that can affect human activity and our technological infrastructure.
Wow, fascinating. So, Kelly, how does space weather actually affect our life here on Earth?
Well, Elsie had alluded to the fact that it challenges our technology. So our power grids are sensitive to those currents that can be induced by this, as well as our satellites could also be impacted by these flares or the space weather. And we get some beautiful things too. We get the aurora out of it.
Have you ever seen the aurora?
I have. It was absolutely beautiful. I laid on the ground for hours in the snow watching it.
So talking about space weather and the activity in our upper atmosphere, how do NOAA and NASA work together to better understand those phenomena?
NOAA is a go-to resource for space weather information. It watches the sun and the Earth 24/7, and it's the nation's official source of forecast warnings and alerts for space weather to help decision makers prevent and mitigate the effects of space weather here on Earth. And in order to do this, we need information, and NOAA works with NASA to